Hello! Today, we're going to explore a fundamental concept from calculus that is absolutely essential for machine learning, the chain rule. A chain rule is a formula to compute the derivative of a composite function. That is, a function that is formed by composing one function with another, like a function inside a function. Think of it like Russian nesting dolls. To get to the innermost doll, you must open each outer doll one by one. A chain rule helps us differentiate through these layers. It has two common forms. On the left is Leibniz's notation, which is great for seeing how the du terms seem to cancel out. On the right is Lagrange's notation. This one clearly shows that we take the derivative of the outer function, f, while keeping the inner function, g of x, inside it, and then multiply by the derivative of the inner function. This detail is crucial and a common point of confusion. Let's see it in action with an example. Let's find the derivative of y equals the quantity x squared plus 1 cubed. First, we identify the inner and outer functions. The outer operation is cubing something. The inner part is the expression being cubed, x squared plus 1. We'll use Leibniz's notation first. Let's define a new variable u for our inner function. This simplifies our main function y to just u cubed. Now, we find the derivative of each part separately. The derivative of y with respect to u is 3u squared, and the derivative of u with respect to x is 2x. Now we apply the chain rule formula. dy dx equals dy du times du dx. We substitute our calculated derivatives into the formula. Our final step is to substitute the original expression for u back into the equation, so our answer is only in terms of x. Now let's try the more direct method. We identify the outer function, let's call it f, and the inner function, g. We find their derivatives. Recalling the formula, we need f prime of g of x. This means we take the derivative of f, which is 3u squared, and plug the entire original inner function g of x back into it. Then we multiply by the derivative of the inner function g prime of x. Both methods lead to the same simplified answer. Let's try a different type of function. Y equals sine of 3x squared. Here, the outer function is the sine function, and the inner function is 3x squared. Again, we'll start by defining u as the inner function, 3x squared. This makes y simply sine of u. The derivative of sine of u with respect to u is cosine of u. The derivative of 3x squared with respect to x is 6x. We combine these using the chain rule, and finally, substitute u back to get the answer in terms of x. Let's look at the direct method, which is faster once you're comfortable with it. First, take the derivative of the outer function sine, which is cosine. Critically, we keep the original inner function, 3x squared, inside the cosine. Then we multiply this by the derivative of the inner function, which is 6x. Again, we arrive at the same answer. Practicing this direct method is key to becoming fluent with the chain rule. So why is this rule the backbone of modern machine learning? It all comes down to a process called backpropagation, which is how neural networks learn. Imagine a tiny piece of a neural network. An input x is transformed into z, which is then passed through an activation function to produce an output a. A network's goal is to adjust its weights, like w, to minimize a loss function. To do this, it needs to know how the loss changes when w changes. This is the derivative of the loss with respect to w. Notice the chain of functions. The loss depends on a depends on z, and z depends on w. To find the derivative of loss with respect to w, we apply the chain rule. The derivative is a product of simpler local derivatives. We find how loss changes with a, how a changes with z, and how z changes with w, and multiply them all together. This is backpropagation. It's the chain rule applied across potentially thousands of layers in a deep neural network. By calculating these chain derivatives, the network learns which weights to adjust and by how much to improve its predictions. Mastering the chain rule is the first and most critical step to truly understanding how neural networks train and learn.